All right, this is the Chapter 9 review for Algebra 2 semester final. The first learning target is I can generate terms of a sequence. Chapter 9 is all about sequences and series. And so a sequence is a list of terms and a series is a summation of a sequence. So the first one is to be able to generate the first 5 terms of the sequence using the explicit formula. Explicit formulas are nice. They let you find any term in the sequence as long as you know the term number. And so every sequence starts with n equals 1. And so we're going to start by putting a 1 in for n. We get 3 times 1 plus 5. That gives us 8. That's our first term. Then we go 2 plus 5, 3 times 3 plus 5, 3 times 4 plus 5, and 3 times 5 plus 5. Those will give us the first 5 terms of our sequence. 6 plus 5 is 11. 9 plus 5 is 14. 12 plus 5 is 17. And 15 plus 5 is 20. So our sequence is 8, 11, 14, 17, and 20. Pause the video now and see if you can come up with the first 5 terms of the next sequence. Check your values with mine. You should have 2, 5, 10, 17, and 26 for the first 5 terms of your sequence. The next objective is that you can write explicit formulas for arithmetic and geometric sequences. And so we talked about these formulas, but we kind of changed this first formula right here for an arithmetic sequence. We said that, oh, this really comes out to be a sub n equals a sub 0 plus n times d. And so we want to, if we can use either formula, they're all about just plugging in values and finding out stuff. But I personally like to use the second formula. It's a little bit easier and quicker. And so we have our first term, so 2, 5, and 8. The first thing you want to find is the difference between them. And so to get from term 1 to term 2, I add 3. To get from term 2 to term 3, I'm adding 3. So that means that your d for all of them is going to be 3. So right off the bat, you can say a sub n equals 3n, plus or minus some value for the 0th term. So to find the 0th term, you want to go backwards. To move backwards, you do the opposite. So you subtract 3 and you get -1. It becomes -1 plus 3n. That is your arithmetic sequence in explicit form. And that's all it is. Now to find a geometric sequence in explicit form, you need to find out what that common ratio is. What are you multiplying every single value by? So to get from 4 to -20, I multiply by a -5. To get from -20 to 100, I'm multiplying by a -5. So my common ratio, R, is -5. Explicit formulas for geometric sequences are very basic. It's your first term. Our first term is 4, times your common ratio, which is -5, all to the n minus 1. And that is it. All the plugging and chugging. Now, these are things that you won't have a formula sheet or anything like that on your final. So you'll have to think about, okay, is this arithmetic or geometric? Start to eliminate some of your choices in your multiple choice, and you may not have the formulas memorized, but you can be able to problem solve through to find the equation that you need. All right, let's move on. Here's the next one. It says, I can find the sums of arithmetic and geometric series. There are 3 summation formulas. The first one is for all arithmetic sequences, or series. The second 2 are for geometric series. This first sum is S of n. That is a geometric series that has an endpoint. Whereas the second sum has no n in it, that is an infinite geometric series. So that is one that has no end. It goes from 0 to infinity for a number of terms. Some infinite geometric series have sums, some do not. And so you need to be aware of that as well. Let's start with this first problem up here. It says 16 plus 23 plus 30 plus ... 100. You have to find out, are we multiplying, are we dividing, are we adding, are we subtracting? To get from 6 to 23, we add 7. To get from 23 to 30, we add 7. It's safe to say that this is arithmetic. And so as you're doing this, what you want to find out is, what is that, how many terms are there in your sequence, or in your series? You need to know, how are you going to get to 100? And the way that you can figure out how do you get to 100 is to work backwards. You have to really write your explicit formula. So your explicit formula says that any term So we can find the value of any term. So if we have 100 as the value of one term, it's going to equal the 0th term. The 0th term, if we go backwards, we subtract 7. That gives us 9 plus n times the common difference. The common difference is 7. We just want to solve that now for n. Subtract 9. We get 91 equals 7n. And we get n to equal 13. That means 100 is the 13th term. Now we have everything we need. We have our n, our a sub 1, and our a sub n. Your first term is, or your n is 13 divided by 2 times the sum of your first term, 16, plus your last term, 100. Type it all in. So 16 plus 100, multiply by 13, divide by 2, and you get that your sum of the first 13 terms is 754. Now, if you have something that's already written for you in summation form, like this second problem, you want to determine, is it arithmetic or is it geometric, first off. And so if you're looking in there, you can kind of, if you're not sure and you can't remember how, you can start to actually figure out what the terms are. So the first term would be 2 times, well, n starts at 1, so you put in a 1, plus 1, that's going to give you 3. The second term is going to be 2 times 2 plus 1. Oh, that's going to be 5. And you start to notice that, oh, all I'm doing each time is I'm adding 2. This is an arithmetic series. So I can use my arithmetic series formula. The first one, s sub n equals the number of terms over 2 times the sum of the first and the last. So the next thing we need to know is the last term. The last term is one, we have 5 for n. 2 times 5 plus 1 gives us 11. So we know that we're going to have the first term, 3 plus 11. Now we need to multiply that by the number of terms divided by 2. Now this is the tricky part. Some of you are going to say that there's too many terms if you're not careful, depending on what those endpoints are. You want to take the last endpoint, the endpoint minus the starting point, add 1. So 5 minus 1 plus 1, and that gives us a total of 5 terms. So it's 5 over 2 times 3 plus 11. So 3 plus 11 times 5 divided by 2. We get 35 for our summation. S sub 5 equals 35. The sum of the first 5 terms is 35. That's what they're asking for. Now we have some geometric series, I believe, here. So if we look at that first one, we want to figure out what are they doing each time. Well, I can say that from 100 to 20, we're dividing by 5. But we want a common ratio, so you want to put that in terms of multiplication. So what we're really doing each time is if we're dividing by 5, we're multiplying by 1/5. So your ratio is 1/5. Now, because it says S sub 6, that means that this is a terminating geometric series. And so we go back and we look. Oh, terminating was that first formula they gave us. The first term times the quantity 1 minus the common ratio to the nth power over 1 minus r. We already know the first term is 100. We already know the common ratio is 1/5. We know that there are 6 terms. Now, when you do this, it's that the entire 1/5 to the 6th power. If you don't put 1/5 in parentheses, you're really just saying it's 1 to the 6th power over 5. And that is not the same thing. All over 1 minus 1/5. Now, use your calculator to help you out. And make sure when you type this in your calculator, if you're typing in 1 minus 1/5 quantity to the 6th, 1/5 should be in parentheses before you raise it to the 6th power. Now multiply by 100. And if you're dividing now by 1 minus 1/5, you should put that in parentheses. And you end up with 124.992. That's your summation. Now, this next one says, does 4 plus 2 plus 1 plus 1/2 converge or diverge? Does it have a sum? If you're looking at this problem and you're kind of confused by the fact that they're asking you if it converges or diverges, you're asking the right question. This should really say 4 plus 2 plus 1 plus 1/2 plus ... You only talk about converging or diverging when you talk about infinite series. Okay, so we want to think about this infinite geometric series. Does it have a sum? We're asking, does it approach a value? So the way that you look at that is you actually look at the common ratio. And so you have to find what are they doing each time. It looks like each time they're multiplying by 1/2. if the common ratio is in between -1 and 1, then it does converge and it has a sum. So 1/2 is in between -1 and 1, so yes, this one does this one converges, we would say. Converges, does it have a sum? If it converges, yes, it should have a sum. Now we actually want to find that sum. And the way we go about finding that sum, go back to the top of the page, they have the formulas up there for you. Our infinite geometric series, it's a sub 1 over 1 minus r. And so it's the first term, which is 4 over 1 minus the common ratio, 1/2. Which is really the same as saying 4 divided by 1/2, which ends up becoming 8. So yes, and the sum is 8. Those are our answers. And that's all we have for Chapter 9 review. My advice for you is to go back through, find that notes packet and look through it. This is one that people struggle with on the final because you haven't used it a lot this semester at all. So go back, take a look at that. We'll be doing a bunch of problems on it on the practice final as well. And this is the end of the Chapter 9 final review notes.